let's talk about the invisible brain that's pretty much running your digital life. It's the reason your phone seems to have an answer for almost anything you can think of. And trust me, it's way more than just a simple search engine. We're going to peel back the curtain. I mean, really think about that for a second. You ask your phone or your smart speaker a pretty specific question, and it just knows. It doesn't just give you a list of websites, it gives you a direct answer. How does it connect that movie title to that director's name? Honestly, it feels like magic. But what's going on behind the scenes is actually way more interesting. So here's the secret. It's all powered by this massive, interconnected web of information. You could almost picture it as a kind of digital brain. And it's not just a boring list of facts. It's more like a map that understands how everything relates to everything else. And this digital brain, well, it has a name. It's called a knowledge graph. And really, it's just what it sounds like. It's a structured way to map out facts. So you've got your entities, things like people, places, movies, ideas, and then you have the relationships, which are basically the lines connecting all those dots. But here's the really elegant part. At its absolute core, every single fact, no matter how complicated it seems, gets broken down into this super simple three-part structure. It's called a triple. You just have a head, a relation, and a tail. That's it. And this right here shows you exactly how it works. Albert Einstein is the head, Nobel Prize is the tail, and the relationship, the line connecting them, winner of. So simple, right? But this is the fundamental building block for that entire digital brain we were talking about. And what's so cool is how this simple little structure can capture pretty much any kind of fact you can imagine. A person winning an award, a director making a film, a city being the capital of a country. Every single one is just another one of those triples, another connection in this huge, ever-expanding web of knowledge. Okay, so we've got this giant map of facts. But a map isn't very useful if you don't know how to read it. So how in the world do we teach a computer to navigate this thing and to actually learn from it? Well, here's the big problem we have to solve first. A computer has no idea what Paris or France actually are. To a machine, those are just random strings of letters. The only language a computer really gets is math. And that right there is the million-dollar question. This is the whole puzzle that researchers in a field called knowledge representation learning have been trying to crack. How do you translate our messy, conceptual world into the clean, cold language of numbers? Well, the solution is just incredibly clever. First, you basically turn every single entity and every relationship into a set of coordinates on a giant, multidimensional concept map. This process is called an embedding. Then you teach the AI that a relationship is like taking a journey on this map. So if you start at the point for Paris and you take the journey called capital of, you should land really, really close to the point for France. Once it learns how these journeys work, the AI can start navigating the map all by itself to find new connections or even predict ones that are missing. And just like with real maps, people are always designing better ones. Some of these concept maps are pretty straightforward, kind of like a grid, but others use way more advanced math, complex shapes and dimensions, to capture trickier relationships, like family trees or cause and effect. The goal is always the same, though: create a map that's as true to the real world as possible. Okay, so the AI knows how to get around the map, but where does the map itself even come from? I mean, how is this enormous brain actually built, and how does it keep growing? Turns out, it really has two big jobs. The first one is all about looking inward, finding and filling in the missing links within its own network. The second job is about looking outward, going out into the chaos of the internet to find brand new facts to add to the map. These two jobs have names: knowledge graph completion and relation extraction. You can think of completion as being like a careful librarian, organizing the shelves and noticing, hey, there's a book missing right here. Relation extraction, on the other hand, is more like a detective, digging through mountains of reports, or in this case, websites and articles, to uncover totally new clues and connections. And that librarian's job? It is absolutely essential. As this quote from the source material makes super clear, no knowledge graph is ever going to be perfect. There are always going to be gaps. So the ability to intelligently predict what should go in those gaps is what makes these systems so incredibly powerful. And to do this, researchers have a whole toolbox of amazing techniques. Some methods use that concept map we talked about to predict where a missing link probably is. Others will actually train little AI agents to act like explorers, finding logical paths through the graph.
Some even use old-school rules of logic to deduce new facts. It's a field that's just buzzing with new ideas.
All right, I know this can all sound a little bit abstract, but the truth is, this invisible brain is working for you behind the scenes every single day. So let's talk about where you're actually seeing this in action. You know when you search for a celebrity or a place or a historical event, and that neat little box of information pops up on the side of the page with the key facts and dates and pictures? Yeah, that's a knowledge graph. It's not just another web page. It's the graph giving you structured, organized data. And hey, remember our first question? When you ask your smart assistant who directed Inception, it's not searching the web. It's querying its knowledge graph. It finds the Inception dot, follows the directed line, and reads back the answer. Christopher Nolan. It's direct, it's fast, and it's accurate. And finally, recommendation engines. How does your streaming service have a clue that because you liked one movie, you might like this other one? It's using a knowledge graph to connect movies through all sorts of things: actors, directors, genres. And then it matches those connections to what it knows about you. So yeah, from the answers you get when you search, to your smart assistant, to the shows you binge watch next, this invisible brain is a huge part of the tech we all use constantly. But as powerful as all this is, we're really just scratching the surface. The next big thing for these digital brains is to tackle some seriously massive challenges, to make them even smarter, even more human-like. And the next steps are enormous. We're talking about moving from simple facts to complex, multi-step reasoning, figuring out how to handle graphs with billions, maybe trillions of connections, making them transparent so the AI can explain why it thinks something is true, and, the Holy Grail, completely automating their creation so they can just learn and grow on their own from the web. And that really brings us to the final thought. We are actively building machines that are getting better and better at understanding the hidden connections in our world. As they keep getting smarter, moving from simple facts to actual reasoning, it leaves us with a really fascinating question to think about. If you could ask this growing global brain anything, what's the one truly hard question you would want it to answer?